Welcome to this introduction video on Blue Demon's ER5356 aluminum welding wire. In this video, we will discuss some of the details of this electrode, some safety concerns and how to deal with them, and a short demonstration of the product. ER5356 is one of the two most popular aluminum filler metals. It is used in the processes of gas tungsten arc welding, GTAW, also known as TIG welding, and in gas metal arc welding, GMAW, better known as MIG welding. One of the first questions you may have about this product: what do the letters and numbers mean? Filler metals are manufactured into different forms and classified into different categories. In our case, the classification is ER, which stands for electrode or rod. Other classifications could include E for electrode, R for rod, or B for brazing, just to name a few. Electrode simply means the filler metal carries the welding current in the process. Adversely, a rod doesn't carry any current and is heated by another source. For the purpose of this video, the number we really want to focus on is in the first position, which in our case is a 5. This digit identifies the primary alloying element of the filler metal. A series 2 would indicate copper, 3 manganese, 4 silicon, and 5 magnesium, just to name a few. The second number identifies specific impurity limits of the wire. The remaining numbers indicate the minimum amount of aluminum of the wire. 5356 comes in roll form for use in the MIG process. It is also manufactured in rod form for use with the TIG process. When using 5356 in the MIG process, you should have your machine set to DC electropositive, DCEP. However, when using the rod form of 5356 to TIG weld, you should set your machine to AC. Both the MIG and TIG processes can utilize 100% argon or a mixture of argon and helium as the shielding gas. Welding positions include flat, vertical, overhead, and horizontal. When selecting an aluminum welding wire, it's always best to know the base materials you're using. In some cases, however, you will not know what materials you have. ER5356 is compatible with all 5000 series aluminums. You should be able to find a materials compatibility chart online to assist you with selecting the proper filler metal for your needs. 5356 is a very popular choice for welding aluminum. It is a general purpose filler metal and has relatively high shear strength. It is commonly used in the automotive industry, shipbuilding, power industry, and trailer manufacturing. With regards to the shipbuilding, ER5356 offers excellent corrosion resistance to saltwater. Check out Blue Demon's website for more product details and instructions on ER5356. Let's stop here for just a moment before I begin the demonstration portion. We need to talk about safety. The welding process can produce harmful light, fumes, sparks, and flying slag, just to name a few. You should always wear the proper clothing and safety gear while welding. This includes, but is certainly not limited to, a welding hood, welding jacket or long sleeve shirt. I would suggest cotton or wool, as synthetic materials may melt to your skin. Next, select the proper thickness of gloves, ear protection, and safety glasses. One should always wear eye protection during the welding process. Here's a tip. Many welders will wear a small respirator, like the one seen here. It filters out some of the harmful things floating in the air. The other thing it does is direct the hot air you breathe down and out of your hood. If you've ever welded before, you know the lens can become so fogged you can't see anything. Other safety concerns exist in your shop. You will want your welding area to be free of flammable materials, such as shop rags or paper towels. You should keep flammable or combustible liquids properly stored away from any source of heat or sparks. Because of the high risk of fire, you'll want to keep a fire extinguisher close by. You'll also want to check electrical cords and cables periodically. You don't want any frayed or exposed wires. Finally, you'll want to make sure all cylinders are secured properly while in use or in storage. Now that we've covered the safety portion, I'll set up a few test coupons and run a few beads. Today, I'll be using Blue Demon's 140 MSTI. This is an inverter style machine that runs on a standard 120 volt outlet. This unit is also referred to as a multi-process welder, which simply means it can weld using multiple processes. I'm relatively new to welding aluminum, so I wanted to pass along some of the helpful tips I've learned in the making of this video. When welding aluminum, it's very important to keep the base metal clean as possible. You should even use a stainless steel brush to break up some of the oxides that form on the outer shell of the aluminum. I've often heard about the 3 C's of welding. However, it was made clear to me that it was extremely important when welding aluminum. With reference to the stainless steel brush, you should keep one that is dedicated totally to aluminum work. This will keep small particles of stainless or carbon steels out of your weld pool. Preheating your aluminum workpiece will help reduce cracks. Preheating isn't always possible. However, for smaller parts, you could use a hot plate. With a smaller welder such as the 140 MSTI, you will want to preheat thicker aluminums. For instance, the parts in this video I had to preheat somewhat for good penetration. The plate had a thickness of 0.188, nearly 1/4 of an inch. When MIG welding carbon steels, you can push or pull the torch. However, when MIG welding aluminum, you should use the push technique. This will help you in 3 ways. As you push the torch, you get better cleaning action to remove oxides. It also reduces weld pool contamination. And finally, it increases shielding gas coverage. When aluminum welds fail, it is usually due to cracking of some type. When you are finishing up the weld bead, you should take extra care to fill in the small crater at the end of the bead. This can be easily achieved by reversing your travel direction when you reach the end of the weld joint. After you reach the end, you can simply pause for a moment and then travel back up the bead for approximately 1/2 inch. This should fill any crater. Here's an example of a crater that can be left at the end of a joint. If you're going to use aluminum wire without a spool gun, you will want to switch out your steel liner to a plastic or Teflon style. A plastic or Teflon liner will ensure consistent and smooth wire feeding through your gun. You will also want to check drive roll alignment to ensure a smooth transition from roll to liner. The last thing I want to pass along is about stick out. When welding carbon steels, you typically want 1/4 to 3/8 of an inch wire stick out. When welding aluminum, you'll want something around 3/4 of an inch. It is my understanding this will save you from burning up a lot of torch tips. I really appreciate you spending your time with me today, and please remember Blue Demon for all your welding needs. Thanks for stopping by, and I'll see you next time.